Hi, it's Graeme Schwenke here. I'm from New South Wales Department of Primary Industries, and today I'm just giving a little talk about some recent work that we've been doing on total nitrogen losses in cropping systems of northern New South Wales, and similar work's been going on in southern Queensland as well. And we've been focused the last 3 years on dryland sorghum crops. So what we've been looking at is using isotope-labeled fertiliser. So the isotope is 15N nitrogen, and the reason we've been using that is a means of tracing the fate of that fertiliser that we put on, usually at sowing with the crop, and we want to see where that fertiliser ends up, by the end of the season, how much goes into the grain, how much goes into the leaves of the crop, and also how much is remaining in the soil. And then by difference, knowing how much we put in at the start, we can calculate the amount of total nitrogen loss. So we've done this in 6 experiments at Tamworth and near Corindi and on the Liverpool Plains at Breezer. There's been another, I think, 11 experiments done in southern Queensland as well, near Toowoomba and Kingaroy predominantly, and all using the same techniques of using this isotope-labeled fertiliser, put in at the start. Now we've put in different rates of fertiliser. We've put it in with, in conjunction with nitrification inhibitors, and we've also looked at the timing of the fertiliser going in. And I guess something to take home from across all of these experiments is that we've had quite surprisingly high total nitrogen losses over the season. So perhaps on average around about 25 to 30% of the nitrogen that we put on at the start of the season hasn't been there either in the plant or in the soil at the end of the season. So we believe that most of that has been lost through the process of denitrification that occurs in soil where there's a low oxygen environment, there's labile carbon, and there's excess nitrate nitrogen available for the microbes to denitrify and turn that nitrate nitrogen into first nitrous oxide, which is a global warming greenhouse gas, and then through to dinitrogen, or N2, which is 80% of the atmosphere is made up of. So, so there's both environmental and agronomic consequences of these losses, and as I said, we've been looking at some different ways of trying to minimise, particularly the losses of the nitrous oxide, but also ways of preventing that overall loss of the dinitrogen. Thanks.